They built a machine that weighed over 1,000,000 pounds. Longer than a 13-story building laid flat on the ground, it could haul 3,600 tons up a mountain. Alone. No second engine, no help. Nothing. And the company that built it, the American Locomotive Company. Most people today have never heard that name. At its peak, the American Locomotive Company ran a single factory in Schenectady, New York. 5,000 workers, 1,000 locomotives a year. They supplied both World Wars, engines and Sherman tanks off the same floor. The man who ran their car program later founded Chrysler. But here's what haunts this story. The American Locomotive Company saw the future coming. They were the first on Earth to build a commercially successful diesel-electric locomotive. Not second. First, and they still lost everything. 68 years, 75,000 machines. One of the greatest industrial empires America ever built. Then, nothing. This is how they rose. This is what they built. And this is the one mistake that erased them from history. Chapter 1. 8 into 1. Before there were highways, before there were cargo planes, before a single 18-wheeler crossed the Rockies, there was the railroad. In the late 1800s, if something moved across America, it moved on iron rails. Coal from Pennsylvania, wheat from Kansas, steel from Pittsburgh. The railroad was not part of the economy. It was the economy. And yet the industry building the machines that powered all of it was a mess. Dozens of small manufacturers scattered across the country, each building to its own specs, each serving its own region. None big enough to invest in new technology, none cheap enough to win on price, none connected enough to service a railroad running 1,000 miles end to end. The men who recognized this were the same men who had just built U.S. Steel, who had consolidated oil under Standard Oil. The playbook was written. Now it was the locomotive industry's turn. In June 1901, 8 manufacturers merged into one. The American Locomotive Company. The founding plants stretched across the East Coast. Brooks Locomotive Works in Dunkirk, New York. Cook Locomotive and Machine Works in Paterson, New Jersey. Dixon Manufacturing in Scranton, Pennsylvania. Manchester Locomotive Works in New Hampshire. Rhode Island Locomotive Works in Providence. Richmond Locomotive Works in Virginia. Then Pittsburgh Locomotive and Car Works. Founded in 1865 by Andrew Carnegie and T.N. Miller. By 1901, Pittsburgh had built over 2,400 locomotives, with engines exported as far as India and Japan. And anchoring everything, Schenectady Locomotive Works. Schenectady had been running since 1848, built by the Norris brothers from Philadelphia. By 1904, that single plant had produced 7,800 engines on 112 acres along Erie Boulevard. It became the headquarters, and the name the whole industry would come to know. Combined output across all facilities, 3,000 locomotives a year. Schenectady alone built 750 of them. To lead it, they chose Samuel Callaway, former president of the New York Central Railroad. Not an engineer, a railroad man who understood both what the factories built and what customers needed. Callaway died in 1904. Albert Pitkin took over. The machine kept moving. In 1902, they acquired the Locomotive and Machine Company of Montreal, renaming it Montreal Locomotive Works. In 1905, they bought Rogers Locomotive Works in Paterson, America's second-largest locomotive manufacturer at the time. That deal pushed the American Locomotive Company to number 2 in the country, behind only Baldwin. Schenectady's location was no coincidence. It sat on the New York-Montreal corridor, close to Pennsylvania's coal and steel, next to the Erie Canal, and directly beside General Electric, a neighbor whose relationship with the American Locomotive Company would define its rise and one day accelerate its fall. 8 companies, 1 city, 1 name. Chapter 2. Fire, steam, and one very expensive mistake. To understand what the American Locomotive Company built, you have to understand what a steam locomotive actually is. You burn coal. The heat boils water inside a sealed steel boiler running at 150 to 300 pounds per square inch. That pressurized steam pushes a piston back and forth. The piston connects to the driving wheels through rods and cranks. The wheels turn. The train moves. No electricity. No diesel. Pure thermodynamics. Fire converted into motion through steel and pressure. To classify these machines, engineers used the white notation system. 3 numbers. Leading wheels at the front that guide the engine but generate no power. Driving wheels in the middle, the ones actually pulling the load. Trailing wheels at the rear supporting a larger firebox. More driving wheels meant more tractive force. A 462 pulled hard. A 484 pulled harder. And some of what the American Locomotive Company would eventually build pushed that system to its absolute limit. The roots in Schenectady ran deep. In September 1868, the Schenectady Locomotive Works built Central Pacific No. 60, a 440 named Jupiter. That engine was disassembled, loaded onto a ship, carried around Cape Horn to San Francisco, transferred to a river barge to Sacramento, then reassembled before it ever ran under its own power. On May 10, 1869, Jupiter stood at Promontory Summit, Utah. One of 2 locomotives meeting at the completion of America's first transcontinental railroad. A golden spike was driven, a continent connected. Schenectady built one of the 2 machines that made it happen. By 1901, the American Locomotive Company inherited that reputation. New York Central, Union Pacific, dozens of regional lines. The Pittsburgh plants had already shipped engines to India and Japan before the merger. After 1901, that network kept expanding. Then came the mistake. In 1906, the American Locomotive Company decided locomotives weren't enough. They formed a subsidiary, the American Locomotive Automobile Company, licensed designs from French manufacturer Berliet, and opened car production inside the Rhode Island Locomotive Works in Providence. 2 years later, they dropped Berliet and started building cars under their own name. The racing results were hard to argue with. Driver Harry Grant won the Vanderbilt Cup in 1909, then won it again in 1910. In 1911, an ALCO car ran in the very first Indianapolis 500. Nobody bought them. The cars were expensive, mechanically complex, built for a market too small to matter. By 1913, the program was dead, shut down after years of losses. It left behind one thing no one expected. The plant manager running that Providence operation was a young executive named Walter P. Chrysler. He left in 1911 for Buick, rose through General Motors, then walked away to start his own company. The Chrysler Corporation, one of the largest automakers in American history, seated inside a failed car program at a locomotive factory. The American Locomotive Company absorbed the lesson. Heavy metal, precision engineering, iron rails. That was the business. They went back to locomotives and never looked sideways again. Chapter 3. The Heart of the Empire. 112 acres. Roughly 85 football fields, all of it factory. The Schenectady complex ran along Erie Boulevard between Knott Street and Freeman's Bridge. From above, it didn't look like a manufacturing plant. It looked like a city. Before the American Locomotive Company existed, the Schenectady Locomotive Works already employed close to 2,000 workers in the 1890s. After the 1901 merger, that number climbed fast. At peak operation, Schenectady alone ran with over 5,000 workers. Combined across all 9 facilities, the company could push out 3,000 locomotives a year. Schenectady's share, more than 1,000 of them. Every single one built from scratch. Right there. Start to finish. The foundry came first. Steel and iron melted down and poured into molds, frames, cylinders, driving wheels. Those wheels alone measured 60 to 80 inches in diameter and weighed tons each. Cast on site, cooled on site, finished on site. Then the forge shop. Crankshafts, connecting rods, coupling joints, hammered into shape under massive steam-powered forging hammers. The precision required was extreme. These parts had to survive millions of load cycles without cracking. A single failure at speed could derail a train. There was no room for sloppy work. Then the boiler shop. Steel plate 35 millimeters thick, cut, bent, welded, and riveted into cylindrical pressure vessels rated for 200 to 300 pounds per square inch. A boiler failure didn't just stop a locomotive, it destroyed it. Workers in that shop understood they were building something that had to hold under conditions that would tear apart lesser materials. Then the assembly floor, where everything converged. Frame, wheels, boiler, steam piping, cab, controls. A large locomotive took weeks to complete, each component fitted and tested by skilled tradesmen working in sequence. No conveyor belts, no automation, just hands and experience. Before anything left the gates, it ran. The testing track inside the complex let workers verify steam pressure, valve timing, and pull response before delivery. Across town, General Electric was building motors and generators. Products that fit alongside ALCO's machines like two halves of a system. No formal agreement at first, just two industrial giants in the same city, with engineers talking to engineers. That proximity would eventually become the most consequential partnership in American railroad history. Schenectady wasn't just a factory town, it was a factory town. ALCO and GE together formed the economic spine of the city. When the plants ran full, the whole city ran. When orders dropped, everyone felt it. In 1929, the American Locomotive Company consolidated. Closed the smaller satellite plants, Dunkirk, Latrobe, and others. Pulled all locomotive production back to Schenectady. Auburn kept its diesel engine work, but everything else came down to one campus, one address. Efficiency went up. Vulnerability went up with it. Every locomotive the American Locomotive Company would build from that point forward came out of one place, the same place General Electric would purchase in 1969, the year the last engine rolled out and the gates finally closed for good. Chapter 4. When Steel Touched the Sky. By the 1920s, American railroads moved over 90% of the country's freight. 3 companies dominated the locomotive market, Baldwin in Philadelphia at number 1, the American Locomotive Company at number 2, Lima in Ohio at number 3. The American Locomotive Company answered with machines that didn't just work. They became icons. The first was the Hudson. The New York Central's Pacific 462 locomotives could handle 9 passenger cars. Trains were stretching to 14, sometimes 18. Chief engineer Paul Kiefer brought the problem to Schenectady. The fix was precise. Add 1 trailing axle, shifting 462 to 464. That axle supported a larger firebox. More firebox meant more steam. More steam meant more power. On February 27, 1927, the first Hudson, New York Central number 5200, Class J1. Left Schenectady. Boiler pressure, 225 pounds per square inch. Driving wheels, 79 inches. Tractive force up more than a third over its predecessor. By 1931, the railroad had 225 of them. The J3A Super Hudsons arrived in 1937. Boiler pressure at 275 pounds per square inch. Overhaul intervals stretched to 200,000 miles. The last 10, numbered 5445 through 5454, wore streamlined shrouding by Henry Dreyfuss in New York Central's Art Deco blue and gray. Those 10 locomotives pulled the 20th Century Limited, New York to Chicago. 960.7 miles in 16 hours at 60 miles per hour average. A trip that once took 20. At full stretch, a Dreyfuss Hudson moved 17 cars at over 90 miles per hour. Every one of those 275 Hudsons is gone. Not one preserved. The most celebrated passenger locomotive class in American history. Completely erased. Next came the Challenger. The 4664 ran on an articulated frame. 2 independent sets of 4 driving wheels that could swivel, letting a machine over 100 feet long negotiate curves a rigid engine could never enter. Union Pacific put them on the overland route through Utah's Wasatch Mountains, grades running 1.14%. Tractive effort, 97,350 pounds. Then came the big boy, and nothing was ever the same. Union Pacific needed to move 3,600 tons, unassisted, across 75 miles between Ogden and Evanston, Wyoming, on grades reaching 1.55%. UP engineer Otto Jabelman set the requirement, 135,000 pounds of tractive effort minimum. The answer was to take the Challenger and scale everything up. Driving wheels from 6+6 to 8+8. Longer boiler, wider firebox, wheel diameter trimmed from 69 to 68 inches to trade speed for pull. The numbers are almost impossible to absorb. Total weight with tender, 1,189,500 pounds. Full length, 132 feet 9 inches. Boiler steel, 35 millimeters thick. Grate area, 150 square feet. Water capacity, 25,000 gallons. Power output, 6,290 horsepower. Tractive effort, 135,375 pounds. Big Boy number 4000 left Schenectady in September 1941. 25 were built in 2 batches. 8 survive. Number 4014 was fully restored by Union Pacific and still operates, the largest working steam locomotive on Earth. But when number 4000 rolled for the first time, the EMDFT diesel had already been on the market for 2 years. Railroads were already signing contracts. The greatest steam locomotive ever built arrived, while the technology replacing it was already winning. In 1945, New York Central ordered 25 more from Schenectady. The Niagara 484, considered technically flawless by engineers who studied it. Not one survives. Diesels retired them all within a decade. The American Locomotive Company had reached the summit of steam. The view was extraordinary. The fall had already started. Chapter 5. Built for War. Twice on December 28, 1917, the United States government did something it had never done before. It took over every privately owned railroad in the country. Not a negotiation, a takeover. America had entered World War I, and the railroad system was choking. Competing companies refused to coordinate. Freight piled up at ports. Troop movements stalled. The United States Railroad Administration, the USRA, was created to run the entire network as one unified system. For locomotive manufacturers, that meant standardization. The USRA designed 12 locomotive types and ordered every builder to produce them from identical drawings. No custom orders, just volume. The American Locomotive Company became one of the primary producers. Between mid-1918 and 1919, the USRA oversaw construction of nearly 1,900 standardized locomotives across the industry. Buried inside that period was a stranger story. Before America entered the war, the American Locomotive Company in Baldwin had accepted an order from Imperial Russia. 400 heavy, 210 decapod freight locomotives for Russian military supply lines. Then the Bolshevik Revolution hit. Russia collapsed as a customer. Roughly 200 of those engines were mid-production with nowhere to go. The USRA stepped in, adjusted the wheel gauges to American standard, and distributed them to domestic railroads. Engines built for the Tsar ended up hauling coal in Pennsylvania. When the USRA dissolved in 1920 and the railroads went private again, the American Locomotive Company kept something valuable: the muscle memory of mass production at scale. They would need it. But first came the floor dropping out. October 1929. The stock market collapsed. Railroad investment froze. Orders at Schenectady fell to nearly nothing. The workforce contracted sharply. Skilled tradesmen who had spent careers in those shops found themselves out of work. Production limped through the early 1930s before recovering late in the decade. Just enough to build the big boy, the Niagara, and the final wave of steam. Then Pearl Harbor, December 7th, 1941. By the next morning, America was at war. The Schenectady floor was partially redirected to armor. The American Locomotive Company built multiple versions of the M4 Sherman. The medium tank used more widely than any other by Allied forces in World War II, and the M3 Lee alongside it. The company's Canadian subsidiary, Montreal Locomotive Works, built nearly 2,000 Ram tanks for the Canadian Army. The Ram 1 with a 2-pound gun, the Ram 2 with a 6-pound gun, both based on the M3 Lee chassis. After the war ended, the American Locomotive Company continued supporting M47 and M48 patent production into the late 1950s. Under Lend-Lease, over 500 locomotives were exported to the Soviet Union from 1942 through 1945. Many were based on the same decapod design first built for Russia in 1916. A blueprint that served 2 world wars across 2 continents, a quarter-century apart. At peak wartime output, Schenectady employed 6,200 workers, the highest number in company history. When the fighting stopped in September 1945, the military contracts stopped with it. Overnight. The question that 4 years of wartime urgency had deferred finally arrived. Steam or diesel? The last domestic steam locomotive the American Locomotive Company ever built was a 284. 7 of them delivered to the Pittsburgh and Lake Erie Railroad in 1948. After that, the boiler shops went cold for good. Chapter 6. The partnership that built everything. Steam didn't lose to diesel because diesel was stronger. A big boy produced over 6,000 horsepower. The early diesels couldn't touch that. Steam lost because diesel was cheaper to run, a lot cheaper. A steam locomotive needed 2 to 4 hours of warm-up before it moved. It required a second crew member whose entire job was managing the coal and fire. It stopped constantly for water and fuel. Its high-pressure boiler demanded expensive, scheduled maintenance. Every mile it ran cost money that a diesel didn't spend. Operating costs on diesel ran 30 to 50% lower than steam. For railroad executives tightening post-war budgets, that number ended the conversation. The American Locomotive Company saw this coming in the 1920s. While Baldwin and Lima were still building steam as if it would last forever, Schenectady was already experimenting with diesel traction. They couldn't do it alone. So they built a three-way alliance. General Electric provided generators and traction motors. Ingersoll Rand supplied the diesel engines. The American Locomotive Company provided the mechanical structure and assembled the whole thing. The result was the world's first commercially successful diesel-electric switcher locomotive. The Central Railroad of New Jersey bought the first one. Long Island Railroad and Chicago and Northwestern followed. In 1929, the American Locomotive Company acquired McIntosh and Seymour Diesel Engine Company in Auburn, New York, bringing engine production in-house instead of depending on a supplier. That plant became the foundation for every diesel engine the company would ever build. The 539 series, the 244, and eventually the 251. The S-series switchers that followed sold over 3,000 units total. The most commercially successful product line in company history. Then, in 1941, came the RS-1, the world's first road switcher. Light enough for yard work, powerful enough for mainline service. The center cab layout with visibility in both directions became the template for diesel locomotive design everywhere. Nearly 1,800 RS series units were eventually sold. The RS-3 alone, 1,418 units between 1950 and 1956, delivered to railroads in the U.S., Canada, Brazil, and Mexico, was dependable enough to hold the company's reputation together through the first half of the decade. Then came the PA, and the damage it did lasted for years. The PA launched in 1946. A long-nosed, streamlined passenger diesel, widely considered the most beautiful diesel locomotive ever built in America. Under the hood, the new 244 engine, V12, 2,000 horsepower. In lighter service, the 244 ran adequately. But the PA pulled passenger trains continuously at high speed for hundreds of miles at a stretch. Under that load, the engine failed. Frequently, maintenance bills climbed, railroads told each other. Total sales, just over 200 units. It was a commercial disaster, and it poisoned every sales conversation the American Locomotive Company had afterward. In 1953, General Electric ended the partnership. They had spent decades on the inside of the locomotive business, supplying components and watching the margins closely. Now they wanted the revenue. GE walked away and began building their own locomotives from the ground up, using everything they had learned from 30 years inside the alliance. The American Locomotive Company switched to electrical components from other suppliers and carried on. Maintenance shops already carrying EMD's electrical inventory now had to stock an entirely separate set of parts for ALCO machines. Complexity went up. Costs went up. Purchasing managers started steering orders elsewhere. By 1964, the situation was bad enough that the company reversed course and returned to GE electrical components, just to stop the bleeding. 11 years of market share. Gone. And the partner they went crawling back to was the same company that was now their most dangerous competitor. Chapter 7. Fighting General Motors with a Pocket Knife. The American Locomotive Company's real problem wasn't the PA. It wasn't the 244 engine. It wasn't even losing General Electric. The real problem was who they were fighting and how outgunned they were from the very first day. Electromotive Division, EMD, was a division of General Motors. The largest automaker on Earth, unlimited capital, a nationwide service network already built, an engineering budget that dwarfed anything Schenectady could match. In 1939, EMD loaded their new FT freight locomotive onto the rails and sent it on a national demonstration tour. Every terrain, every grade, every climate. The locomotive hauled heavy freight through the Rockies, across the desert Southwest, through deep South humidity. Railroad after railroad watched it perform and signed contracts before the locomotive even left their property. That tour didn't just sell locomotives. It changed what railroads believed was possible with diesel. Every steam-era manufacturer felt the aftershock. World War II paused EMD briefly. When it ended, they came back with momentum nothing slowed. By the early 1950s, EMD held 70 to 75% of the American diesel market. The American Locomotive Company sat at 15 to 20%. Number 2 on paper. A distant second in practice, with the gap growing every year. Geography compounded it. EMD's plant in La Grange, Illinois, sat near the center of the country. Railroads in Texas, California, and the Mountain West had shorter supply lines to La Grange than to Schenectady on the northeastern edge of the map. When a locomotive needed parts or a technician, EMD could respond faster almost everywhere. In an industry where a broken locomotive is a broken schedule, response time is not a minor variable. EMD's training programs widened the gap. They built dedicated schools for railroad engineers and maintenance workers. A worker trained on EMD equipment trusted EMD equipment. When purchasing decisions came up, that worker recommended what they knew. Familiarity became preference. Preference became procurement policy. The American Locomotive Company had nothing comparable. Part standardization locked it in. EMD's 567 engine, later the 645, then the 710, shared components across model lines for decades. A single inventory served a dozen models. Every locomotive the American Locomotive Company sold added a separate, incompatible parts requirement that showed up in railroad budgets every single quarter. The American Locomotive Company's own decisions kept compounding the damage. The FA freight locomotives, 1,401 units built between 1946 and 1956, used the same 244 engine as the PA. In lighter freight service, it ran better. But the 244 still used a wet liner design, cylinder sleeve in direct contact with engine coolant. Contamination risk was higher. Maintenance intervals were shorter. EMD's dry liner configuration was simpler and more forgiving. Roundhouse foremen noticed, wrote it into their logs, and remembered it the next time a salesman knocked. Then the aluminum wiring. On diesel models through the 1950s, the American Locomotive Company wired their locomotives with aluminum instead of copper to cut costs. Aluminum carries higher electrical resistance than copper. At loose connections, and vibration loosens connections over thousands of track miles. Resistance becomes heat. Heat becomes failure, sometimes fire. The company had to send crews back into the field and rewire affected locomotives at their own expense. The reputational damage lasted longer than the repair bills. By 1961, General Electric released the U-25B, 2,500 horsepower, nearly 500 units sold. GE took second place. The American Locomotive Company fell to third. The mid-1960s numbers closed the argument. EMD's GP35 at 2,500 horsepower, over 1,300 units sold. GE's U-25B at the same rating, nearly 500. The American Locomotive Company's C628 at 2,800 horsepower, more powerful than both, 186 units. More powerful, 1/7 the sales. They were not losing because they stopped trying. They were losing because their opponent had General Motors capital, a decade's lead on trust, and systems at every level that made switching away expensive. When a railroad shop knows one brand completely, retraining costs money. Most didn't bother. That is not a gap a better locomotive closes. It is structural, baked in from the moment EMD parked that FT in the first rail yard in 1939. and by the mid-1960s, it had become permanent. Chapter 8. Death by 1,000 Decisions. In 1955, the American Locomotive Company removed the word locomotive from its name. The company became ALCO Products, Incorporated. The official explanation was simple. Locomotives were no longer the dominant product line, and management wanted a broader industrial identity. That was technically accurate, but what it actually signaled was something more damaging. The people running the company had looked at the competition with EMD and decided quietly that they could not win on the core battlefield. Rather than fix that, they chose to leave it. Changing your name doesn't fix your engine. Rebranding doesn't close a 50-point market share gap. It tells the market you've stopped believing in your own fight. The diversification that followed made it worse. Through the late 1950s, ALCO products moved into nuclear energy, oil and gas equipment, chemical processing, and small batch custom manufacturing. The nuclear program ran from 1954 to 1962. 8 years competing against Westinghouse and General Electric in a field requiring expertise neither company had spent decades building. It ended without leaving a mark. Oil, gas, and chemical work generated some revenue, but none of it was scalable, and none of it replaced what was being lost in locomotives. The deeper problem was the company's mindset. ALCO was still operating like a steam-era manufacturer, building custom-engineered solutions one order at a time. That approach had built the big boy. In diesel, it was a liability. Standardized components, repeatable production lines, and fast parts availability were what determined winners. The company needed to think like a volume manufacturer. It was still thinking like a craftsman. The aftermarket business collapsed alongside new sales in a tight, self-reinforcing loop. Fewer locomotives sold meant fewer in the field. Fewer in the field meant fewer overhaul contracts and parts orders. Less service revenue meant less capital for new development. Weaker products meant fewer sales. The cycle tightened every year. EMD's rebuild center in La Grange sat at the geographic center of the country. Western railroads could get locomotives there and back faster than a Schenectady round trip allowed. ALCO had counted on capturing a major share of the rebuild market when they built it. They captured almost none of it. The Century Series launched in 1963 was the last serious attempt to reverse the damage. Century, a new era, a reset. The lineup ran from the C420 at 2,000 horsepower through the C424 at 2,400, the C628 at 2,800, the C630 at 3,000. At the top sat the C636, a 251 FV16 producing 3,600 horsepower, the most powerful single-engine diesel the company had ever built. The numbers looked impressive on a spec sheet. They looked different in the field. The C628 outweighed every comparable competitor by at least 30 tons. The C636, fully ballasted, reached 420,000 pounds, against EMD's S-40 at 368,000 and GE's U30C at 363,000. That weight punished track infrastructure. Railroads on lightly maintained lines reported accelerated wear on ties and rail after running Century locomotives. Powerful machines that damaged the roads they ran on were machines railroads quietly stopped buying. The C636 demonstration program sealed it. During evaluation runs on the Santa Fe and Southern Pacific, the same traction motor blower failed on 3 out of 4 test runs. The same part, 3 out of 4 times. Potential customers watched it happen in real time and walked away. Total production at Schenectady, 34 units. The C415 switcher, introduced in 1966, was a different kind of failure. Engineers designed it with an offset center cab. Engine at one end, radiator at the other. The split required longer wiring, longer piping, and a longer drive shaft between components that should have been adjacent. The result was more complex, less reliable, and harder to maintain than the design it replaced. It sold 26 units total. That same year, EMD's SW1500 entered production. It eventually sold over 800. The Hiad truck, introduced mid-decade, positioned as a traction improvement, was in practice a copy of an EMD design. The company that invented the road switcher in 1941 was now reverse engineering its competitor's undercarriage. In December 1964, the Worthington Corporation acquired ALCO products. By 1967, Worthington merged with Studebaker to form Studebaker-Worthington. The people now running the locomotive division were financial operators. They evaluated it the way any acquisition manager evaluates a struggling asset. Numbers on a page with no particular attachment to the product or what building it right actually required. The end was no longer a question of whether. It was only a question of when. Chapter 9. The Last Engine and What Remained. January 8, 1969. A T6 switcher, road number 1016, rolled out of the Schenectady plant and was delivered to the Newburgh and South Shore Railway. 2 days later, on January 10th, number 1017 followed. Those were the last 2 locomotives the American Locomotive Company ever built on American soil. Full stop. No ceremony. No press release. No final speech on the floor. No photograph of the last shift clocking out. 2 small yard engines heading to a short line railroad in New York State, and then the gates closing behind them. 68 years. That is how long the American Locomotive Company operated. From the merger of 8 manufacturers in June 1901 to those 2 switchers rolling out in January 1969. 68 years was longer than the average American life expectancy at the turn of the century when this company was born. It had outlasted 2 world wars, the Great Depression, the entire age of steam, and nearly 2 decades of diesel. Then it was over and done. Worthington broke the company apart and sold the pieces separately. The diesel engine operation from Auburn, New York, continued under new ownership. The Schenectady plant itself, 112 acres along Erie Boulevard, the forge shops, the foundry, the assembly halls, the test track, was purchased by General Electric, the same General Electric that had been the company's partner for 3 decades. The same company that had walked away from that partnership in 1953 to build locomotives of their own. They bought the land. They built GE locomotives on the same ground where the big boy had been assembled. There is no gentle word for what that is. The partner became the inheritor. In Montreal, the story continued a little longer. Montreal Locomotive Works, the Canadian subsidiary owned since 1902, kept running after Schenectady closed. Under the name MLW Worthington, the plant produced locomotives based on ALCO designs for Canadian railroads and export markets. The M630 and M636 found buyers in South America and Australia. The M420 sold steadily within Canada. MLW survived until June 23, 1978, nearly a decade after the American plant went dark. When it finally closed, the assets went to Les Entreprises Bombardier, a transaction that became the foundation of Bombardier Transportation, one of the largest rail equipment manufacturers operating in the world today. The direct lineage runs from a locomotive works in Montreal, opened under American Locomotive Company ownership in 1902, to a global transportation company still building trains in the 21st century. Back in Schenectady, the damage did not heal quickly. Thousands of skilled workers lost their jobs when the plant closed. Machinists, metallurgists, boilermakers, electricians, men who had spent entire careers inside those buildings. The neighborhoods built to house them lost their economic foundation. Businesses closed, families left, the tax base eroded, the physical plant decayed. Asbestos, used widely in insulation, pipe covering, gaskets, and structural materials well into the 1960s, had contaminated the soil and structures across the site. Environmental remediation took decades. The cleanup outlasted multiple city administrations. Schenectady became one of the clearest examples of what the press would call the Rust Belt. The band of former industrial cities across the Northeast and Midwest, where factory closures left damage that persisted for generations. General Electric, the other pillar of the city's economy, contracted steadily through the same years. The city had been built around two giants. It watched both of them shrink. What remained of the American Locomotive Company survived in scattered forms. Fairbanks Morse engine markets an engine line today under the FM pipe ALCO brand. The ALCO 251 Prime Mover, the most reliable diesel engine the company ever built, continued development through MLW and successor companies across multiple countries. Versions of that engine design are still running in revenue service today, more than half a century after the company that created it stopped existing. And the machines themselves. 8 big boys survived. 7 stand in museums and parks. Number 4004 in Cheyenne, Wyoming. 4005 in Portland, Oregon. 4006 in Dallas, Texas. 4012 at Steamtown National Historic Site in Scranton, Pennsylvania. 4017 in Pomona, California. 4018 in Denver, Colorado. 4023 at Kennefic Park in Omaha, Nebraska. The 8th, number 4014, runs. Union Pacific restored it to full operating condition and returned it to service as part of their heritage fleet. It has pulled excursion trains across the western United States. A machine built in Schenectady in 1941, weighing over 1 million pounds, still moving under its own power in the 21st century. The company that built it is gone. The factory is gone. But number 4014 keeps running, louder and heavier than anything else on those rails, as if it has not yet received word that the story is supposed to be finished. Chapter 10. 6 Things the American Locomotive Company taught us before we close. Let's be honest about what this story actually is. The American Locomotive Company did not fail because they ran out of engineers. They built the Hudson, the Challenger, the Big Boy, the Niagara. These were not the products of a company that had run out of ideas. They were built by some of the finest mechanical minds in the country, working at the absolute outer edge of what steel and pressurized steam could physically do. What they lacked was harder to build than a locomotive. And the lessons from their collapse are worth sitting with, because every one of them is still playing out somewhere right now, in a different industry, with different names on the door. Lesson 1. A merger creates scale. It does not create survival instincts. In 1901, 8 struggling manufacturers merged into one powerful company. The consolidation made sense. It removed waste, pooled capital, and built something that could compete nationally. But the company that eventually beat them was not one of the old guard. EMD was a new division of General Motors, built from scratch with diesel as its entire purpose. It had no steam-era habits to unlearn, no legacy customers to protect, and no craftsman's pride attached to a technology that was already dying. Strength at the start is real. It builds a position, but it doesn't compound on its own. You have to keep earning it every single year. Lesson 2. Seeing the future correctly means nothing if you execute it wrong. The American Locomotive Company identified the diesel transition a decade before most of their competitors. They built the world's first commercially successful diesel-electric switcher. They were first. Then they rushed the 244 engine into production before it was ready. The failures in the PA and FA were public, documented, and repeated. Railroads remembered. In industrial markets, a machine that breaks down doesn't just lose the next sale. It loses the next decade of sales at every property whose maintenance foreman has that failure logged in his memory. EMD was later to the market. But they were careful. When the FT went on tour in 1939, it worked. It kept working. First mover advantage only holds if your product holds up long enough to build trust. Lesson 3. Your best partner can become your most dangerous competitor, and that transition is permanent. General Electric spent 3 decades inside the American Locomotive Company's business. They understood the customers, the technology, and the margins. In 1953, they decided they'd rather own the market than supply it. The immediate damage was visible. Incompatible components, maintenance headaches for customers, years of lost share. But the deeper damage came after. GE used everything learned from the partnership to build a competing product line, took second place in the market by 1961, and eventually became the dominant force in North American locomotive manufacturing. When a strategic partner walks out the door, the question is never only what you lost, it is what they just gained, and what they are about to do with it. Lesson 4. Rebranding in the face of a structural problem is not a strategy. It is a public admission. In 1955, the company removed Locomotive from its own name. Management poured energy into nuclear reactors, oil field equipment, and chemical processing. None of it fixed the 244 engine. None of it trained a single railroad crew to trust ALCO machines. None of it built a service network that could respond to a breakdown in Kansas. Every resource spent chasing nuclear contracts and chemical equipment was a resource not spent on the actual problem. Resources are finite. Where you point them is the only decision that ultimately matters. Lesson 5. After-sales service is not overhead. It is a moat. EMD won the American market not just because their machines ran well. They won because they made switching away expensive. Training programs meant every railroad's maintenance staff knew EMD equipment inside out. Parts standardization meant one inventory served dozens of models. A plant in LaGrange meant fast turnaround anywhere in the country. By the time a railroad had trained its people on EMD, stocked its shelves for EMD, and built its workflows around EMD, changing suppliers cost serious money. That switching cost was not accidental. It was engineered. The American Locomotive Company never built anything close to it. Lesson 6. Comfortable second place is a slow way to disappear. Through the 1950s, the company held 15 to 20% of the market, enough to survive, not enough to generate the investment needed to close the gap. The stability of a survivable position dulled the urgency of a competitive one. When GE pushed aggressively in the early 1960s, there was no cushion left. ALCO fell from second to third with nothing in reserve to fight back with. 68 years, 75,000 locomotives, 2 world wars, Sherman tanks, the most powerful steam locomotive ever built still running today. The American Locomotive Company didn't fail because the talent left or the will ran out. They failed because the world shifted and they could not shift fast enough or in the right direction to stay on it. That is not a story about one factory in upstate New York. Every industry has its 1939 moment, the year the FT rolled out and most people in the steam business still believed they had decades left. The only question that has ever mattered is whether the people inside the building can see it coming, and whether they have the nerve to act before the gates close behind the last machine.